Well, welcome to our Unit 6 review of Calc Medic. We're getting into antiderivatives and their usefulness now, so we're in the second half of what we've learned in calculus. So, of course, we know that integrals are useful for area, but their more useful application is in word problems when we're talking about accumulation. And so we want to review that today. So let's start with the definition of this integral. Yes, it represents area, but it also represents f of capital. Remember, the capital stands for the antiderivative. F of b minus capital F of a. That leads us to the fundamental theorem of calculus, which is just a rearranging of those terms. And if we isolate f of b, we get that capital F of b alone is capital F of a plus the integral from a to b of the lowercase f of x function. That's the fundamental theorem of calculus. Often you are asked to find capital F of b. So I'm going to label this as the FTC. Okay, fundamental theorem of calculus. So a lot of times you are given, find f of 3, given that f of 2 equals 7. Well, then you're going to put 7 there, and then your integral will start with 2, and then it will end at 3. Okay, that value. So you're starting with an accumulated initial condition of 7, and then your integral is starting at 2 and ending at the b value that you're given. So that's the fundamental theorem. Interpretation in terms of remembering what this means for an accumulation problem. You're going to see words like net change in blank. Or, I'm going to erase that here, or accumulation of blank. You'll see words like that, right? And that is a to b of f of x dx. All right, but if you see total change, okay, that word total is significant because the integral then requires an absolute value. All right, so that is a key multiple choice problem. We'll throw the word total in there, and if you leave the absolute value off, you're going to find the answer that you get without it as one of those choices. And so you want to remember to put, when you're specifically referencing total, that disregards all positive and negative. It makes everything positive. And so you want to be finding the total. If you're doing net change, you leave the absolute values off. The negative stuff stays negative, the positive stuff stays positive. So make sure that you are keenly aware of the difference in vocabulary. The other thing is, and we've stressed this all year, is to be cognizant and aware of your units. And so you'll have the whatever the units of f are multiplied by whatever the units of the dx are. We multiply units together, which is how we end up going from, say, meters per second times seconds to get us to meters. So always be watching how your units go. So here's an example where you'll be given a graph, not necessarily a function, but a graph, and you're asked to do an accumulation problem. So let's assume that the graph represents people who are going into a store. Now I want you to be watching out for that because that's one of your AP exam tips here today. All right, so FRQs often have entering and exit problems. All right, so we're talking about, we have to watch for both of those values. You can't just ignore you know, the 1. Make sure that you're aware that there's probably going to be some subtraction as they cancel each other out. So let's see, often problems. Okay, so let's look back at this. We've got P of T, and let's look at what P of T is measured in, people per hour. Okay, and this is the people that are going in. And then T is measured in hours itself. So we've got our time, and we are starting at 6 a.m. So that's important to recognize too. What time of day are you starting? Also, the initial condition is super important because that would adjust your answer. So at time 0, there are 12 people in the store. Well, how could there be 12 people in the store at the starting of time? Well, these are the people who work there. All right, they are the cashiers and whatever. So they are waiting in the store, and they open the doors and they're waiting for the people to enter. So the question is, how many people have entered the store between 8 a.m. and 10 a.m.? All right, how many people have entered? So we want to write an integral. Always write an integral when you're talking about a accumulation problem. There's another tip. All right, don't skip writing the integral. Always write it down. It's worth points. So even if you're going to do the geometry from the graph, always write the integral down to earn easy points. All right, so what would our integral be? Well, if we want to go from 8 a.m., which is time 2 hours after we open it, to 10 a.m., our integral would be from 2 to 4, that's 8 a.m. to 10 p.m., the integral of P of T dt. Now remember the units, we're going to be multiplying here. The P is measured in people per hour, and the time units are measured in hours, and so the multiplication here would yield something in people. All right, so write it down. Even if that was all you wrote down, you can get points for that. Now let's go and look at the geometry. So we're looking at 2 to 4. So we've got one trapezoid next to another trapezoid. So we're going to do a couple traps here. And so we're going to have 1/2 of the base times 1, and then the heights of 80 plus 180. And the other would be 1/2, and the base is 1. And then we've got the trapezoid of 180 plus 120. So we're looking at 1/2 of 260 and 1/2 of 300. So that's 130 plus 150. So we're looking at 280 people. All right, next question. Between 7 a.m. and 9 a.m., people are leaving the store. Okay, so now we have people leaving. Here's where you have your exit things at a constant rate of 30 people per hour. So how many people are actually in the store at 9 a.m.? So this requires a couple things. It requires the number of people who started in the store, that's your initial condition, the number of people who entered the store, and the number of people who left after they were done shopping. So we have to start with the number 12. That is the initial condition of how many people are in the store. Then we're going to write our integral to represent the people who are going in. And the people who are going in are the P of T people. And they are going in from the beginning until 9 a.m. So that's 0 to 3. Then we are going to subtract the people who have left. Only they started leaving at a different time. They didn't start leaving till 7 a.m., which is 1 hour into it until 3. And the constant rate there of 30 people per hour dt. So again, write your integral down. Earn those easy points. Start with your initial condition. Earn those easy points. So that's another AP exam tip. Always remember the initial condition. Again, that's going to be important on a multiple choice because nobody can give you partial credit for that. That initial condition is going to be the difference between choices on the multiple choice, between your options. Okay, so we want to go from 0 to 3, and we've got starting with 12. So 0 to 3, well now we have a different trapezoid we're looking at from 0 to 2 here. So we're going to have a trapezoid that's 1/2 of a base of 2 this time, times my heights of 40 plus 80, and then plus, we already have the other trapezoid, the 1/2 of the base of 1 and 80 plus 180, so we already had that one. And then minus 30t plus c is the antiderivative from 1 to 3. So we have 12 plus 120 plus 130 minus 30 times 3 plus 30 times 1. Okay, so everything all plugged in there. That gives me a total of 202 people are actually in the store at 9 a.m. at that time. Okay, so any other exam tips to leave you with? Remember the difference between net versus total. And the difference there is that absolute value that's inside, not outside, inside of the integral sign. All right, so good luck with your MEDIC number 6 problems tonight, and we'll talk about MEDIC 6 and 7 questions together on Friday. All right, see you then.